Hello students, so today we'll go for the next concept of change in spectra, okay, upon coordination with sulfate. So this is what, okay, so we'll study regarding the change of the spectra, also according to change in the symmetry upon the coordination of some of the anions like SO4 minus 2. So the sulfato complex sulfate, this is called as sulfato, okay, SAL, sulfato. So the free sulfate ion belongs to high symmetry of point group tetrahedral. Okay, so this belongs to the point group tetrahedral, high symmetry tetrahedral, and it is going to show the four fundamental vibrations, and only nu3 and nu4 are IR active. So out of this four, only nu3 and nu4 are IR active. Okay, so nu1 nu2 that is not so much, but nu3 nu4 are IR active here of the four vibrations. If the symmetry of the ion is lowered by complex formation, then the degenerate vibration split and the Raman active modes appear in the IR spectrum here. Okay, so the lowering of symmetry is caused by coordination in is different for the unidentate and bidentate complexes. Like you can see that the sulfate may have in this way. Okay, this is one way of the tetrahedral structure of the free ion. Okay, or it may have the monodentate type of you can see like this, and it is going to bind with metal. So this is second type of vibrations we can see, that is unidentate complex, which is having C3V point group. Okay, and unidentate complex, and also you can see that sometimes it is like bridged metal. Okay, this is bidentate complex, and C2V point group, and the last one you can see that it is in the form of bridged, okay, sulfur, and it is in the form of like this. Okay, so here metal and here metal, so it is in the form of bridged bidentate and having C2V C2V, so C2V C3V here. Okay, and free ion, so tetrahedral. So like this, this is how the four modes of the 4 modes of the vibration, among which the nu3 and nu4 will be the IR active. Okay, so this is how about the sulfate ion, and the change in the it is caused the lowering of the symmetry, you can see, and the frequencies according to the changes here. Okay, and you can see them spectra of cobalt 3. Okay, spectra of cobalt 3 sulfato was cobalt 3 sulfato. Okay, complexes was obtained by the Nakamoto in you can see in complex like cobalt NH3 6 times twice SO4. Okay, cobalt NH3 6 times twice NH3 6 times twice SO4 thrice 5H2O. So you can see that this complex nu3, so you can see here, so in this complex nu3 and nu4 do not split. Okay, here nu3 and nu4 they don't split. Okay, nu3 nu4 they don't split in this complex, and nu2 does not appear, so nu2 is not appeared here. Okay, but new one is observed, so here, and it's very weak. New one is observed in this complex, but it is in a weak. So new in observed, new 2 is not appearing, new 3 new 4 they don't split here. So this is what about this specificity of this complex sulfato upon coordinated with this cobalt 3. Okay, this was observed by Nakamoto. Okay, so they haven't so with this they concluded that the symmetry of the sulfate ion is approximately tetrahedral. Okay, so in one of the case, in one more complex is that is cobalt. Okay, so in this complex cobalt NH3 5 times SO4Br. So in bromide halide is there. So here both nu1 nu2 appear with medium intensity. Here both nu1 nu2 was seen with medium intensity. Okay, this was seen in both nu1 nu2 in this complex, but they are medium intensity. And nu3 nu4 each splits in two bands. Nu3 nu4 they splitted in two bands. They splitted in two bands. So this was the case in this complex. Okay? So this is how you can see that upon binding with the sulfate ion, there is a change in as the change in the symmetry. So IR spectra also has different absorbance in these cases. Okay, and this can be explained. Okay, and the symmetry, and you can see that the lowering of symmetry is taking place from tetrahedral so C3V. That is a unidentate coordination in the complex. Okay, in the complex like bridged complex cobalt NH2. Here it is means here this is what sulfate here. Okay, so cobalt and here NH3 4 times. This complex you can see that there is a lowering in the symmetry from tetrahedral to C3V. Okay, so which is unidentate coordinated in here in both nu1 and nu2. So it's here is appearing in the medium intensity, and nu3 and nu4 can splits into three bands. Okay, so this results the symmetries are further lowered and probably reduced to C2V. So this is what happens here, and thus you can see the sulfate group in this complex is to bridged bidentate. Okay, in this form. So the chelating bidentate sulfate group it was discovered by Tobe. It was discovered by Tobe chelating sulfate group, and he observed the three bands. Okay, near 11211 and 1176 and 1075 per centimeter. So these three bands he observed 1211 1176 10 per centimeter in the nu3 region of nu3. Okay, region of this complex. Which complex? CO cobalt ethylene diamine this sulfate bromide Br. So this is what the complex. So where he observed the three bands here. So he observed the three bands. Okay, in the nu3 region. So these frequencies are higher, was seen to be higher than those of the bridged bidentate complexes. So this is how. Okay, and you can see this table. From this I have taken one spectra for this sulfate here. So we can see the sulfate here. So nu1 nu2 sulfate of the ions here. Okay, so this is for the cobalt hexaamine sulfate 5H2O thick line. So this big dotted line you can see for this cobalt hexaamine sulfate bromide. Okay, so this is what where sulfate is coordinated inside this here. Here it is outside, and here it is unidentate by the bridged form here sulfate. Now just we studied here. So this is what. Okay, so C3V and different this is there. So you can see here the absorption here. So vibration frequency of cobalt 3. So here you can see this is different. So here you can see here. Okay, so nu1 nu3 nu3 nu3. So weak band, and this is, you can observe here. So a table you have given here. So here nu1 nu3 nu3. So almost nu3 nu1. So nu1 is very weak, so nu3 and nu4 they are most seen in the vibration frequency. Okay, which is we can say very this one sharp here. So we can see here some of the compound and symmetry here. So I have taken this one. So compound here free sulfate, you can see symmetry is perfectly tetrahedral. It is not going to show nu1 nu2, but nu3 is showing at 1104. That is very strong peak here, and nu4 is 613. It's also strong. So 613 it is coming here. Okay, now if you see this complex, now this is about the free sulfate. If you see this next complex of dihexaamine cobalt sulfate, which is also a tetrahedral complex. So this showing a very weak vibration of nu1, that at 973 per centimeter. Nu2 is not observed, but nu3 again it's a strong 1130. That is very strong here. Nu3 and nu4 also 613 is strong. See here. So these two are IR very strongly they are observed, whereas nu1 nu2 are weak, and in some cases they are not observed also, like in free sulfate here. So another C3b you can see here. So C3b complex UNH365 penta, okay, sulfate bromide. So this is having the geometry of C3b. You can see new one, it's showing weak again here of 970 per centimeter. Then you can see here new 2 also medium you are observing in this complex 438. See how upon a coordination with sulfate how they are changing here. New as usual, so new 3 is very sharp at 4 103 to 1 not other vibration also it will show, and 645 and 604 is strong vibrations of new 4 shown by this complex. And last one is this complex where our spectra is here. So this complex, so the peak you can see here, new 1 new 3 new 3 new 3. So you can see us is having C2V point group, and new one is a medium here. So you can see here 995 per meter. So you are going to get the medium here 995. So somewhat here new ones here. This is what, okay, this is what we are going to get 995 here, which is medium here. And next new 2 we are going to set 462. Again it is medium 460. It is not in the range here. So this also is medium new 2, and you can see here very strong we can see at 1050. So 1050. So somewhat new 3 here 1050, somewhat here strong. All 3 are there, so they are by for 1060 like this 1050 1060. So in this range you are going to get here. And in the medium you can see new 4. In the strong it will be 641 610. So scale is not here, so it is going to show at 641 means strong and 517 medium. So like this, so different complex with different symmetry you can see here. So C2V C3V tetrahedral. So new 1 new 2 new 3 new 4, the vibrations changes accordingly with the coordination of the sulfate ions. So here see how it is coordinated in this. Here it is outside, here it is like this, and here it is in the bridge form unidental. So in this way also, in this way we can see that there is even change in the in this vibrational frequencies. Okay, so this is how, and even in the unidented coordinated of sulfato group of trans, okay, of trans ruthenium RuSO4, okay, NH3 ruthenium. So this is what complex is Cl. So you can take it nitrosamine Cl chloride. Okay, this also been studied, and the symmetries of the sulfate ions in metals, various stages of hydration also have been studied with IR spectroscopy. Okay, so this is how I think so more than sufficient to know how the spectral changes is occurring in the presence of the sulfate ions. Okay, in the next class we'll go for the chlorate ClO4 minus ions. Thank you.